And welcome. My name is Danny Rajan Jacob, and I'm with my colleague Kevin Varghese Roy. And this is our project, which is a video presentation on digital electronics, which is based on the topic registers. First, let's have a look at the introduction. It is a group of binary storage cells suitable for holding binary information. An n bit register has a group of n flip-flops and is capable of storing binary information containing n bits. In digital electronics, registers are small, fast storage units within a processor or digital system used to hold data temporarily. They are made up of flip-flops, which are biostable circuits that can store one bit of data each. Registers are typically used for various purposes such as holding intermediate data, storing instructions, or storing memory addresses during computation. Now, let's have a look at the characteristics. The first one is fast access. Registers provide very fast access to data as they are located inside the processor. Then the next one is the bit width. The size of a register typically matches the architecture of the processor, such as 8-bit, 16-bit, 32-bit, etc., or 64-bit. Now the third one is the temporary storage that it gives. Data in registers is not stored permanently, it is temporary and often gets overwritten or used for further processing. Now the synchronous. Registers usually work synchronously with a clock signal, meaning their data changes at specific clock edges. Now let's have a look at the first type, which is a 4-bit register. Here, register is constructed with the help of a D flip-flop. Information present at data inputs are transferred to Q outputs when clock goes high. Output follows the same input as long as clock remains 1. When clock goes to 0, information present at data input just before transitions is retained at Q output. Now we have the next type, which is the shift register. A shift register, binary data in a register can be moved with register from one flip-flop to another. Register that allow this type of data transfer is called the shift register. It is a sequential circuit which stop data and shift that data towards output on every clock signal. It may be either from the left or to the right. There are mainly of 4 types. The first one is serial in serial out, or rather SISO. The second type is serial in parallel out, SIPO. The third one is parallel in serial out, PISO. And the fourth one is parallel in parallel out, PIPO. Now I would like to hand over to my colleague Kevin Varghese Roy.
Okay, thank you, Danny. So let's just go through the 4 types of shift registers that we have. So moving on to the first register, the serial in serial out, or rather we call SISO. The SISO is a kind of shift register where data loading and retrieval occurs in the serial mode. A basic SISO register is constructed with the help of a flip-flop. So right here we have an image of what the SISO is all about. So here we have a single output, and the single output travels just same as the triggering that we learned in the digital electronics. And there's also a serial output and a serial input, and we also have a clock signal. And that's all I can say for right now. Let's move on to the next one, which is serial in and parallel out, which is also commonly known as SIPO. Here data is stored in the register serially, while data retrieved from the register is in parallel mode. So I would like to repeat once again, data is stored in the register, meaning the input is given in serially, while the data retrieved, which is the output, is in parallel mode. For storing a 1-bit data word, we need 4 clock pulse, meaning the clock pulse value might be 4 in the sense, and at the end for the 4 clock pulse, this data word will be available in 4 output pins of the 4 flip-flops. Now let's move on to the third one, which is PISO, which is parallel in serial out. For PISO, input 4 flip-flops are given at the same time parallel in single clock pulse. Here data retrieval is also in serial mode. Data retrieval as in the sense input is in serial mode, and the output is, I have no idea. But let's move on to the third point. Is that so we need next 4 clock pulse also to retrieve the stored 4-bit data from the word piso. Now it's last but not least, we are going to the parallel in, parallel out people. Here data storage and retrieval are in the parallel mode, meaning the input is also from the parallel and output is also from the parallel. Same as such, we have a triggering diagram, and this is the end of this session. So I would like to thank everyone for watching our video presentation. So this is me, Kevin Verghese Roy.
This is me, Danny Rachan Jacob, signing off.